Okay, for this section, we're going to be doing Chapter 10, Section 1, which is all about writing and balancing equations. So you should have this sheet out. These are your guided notes. We'll look through everything on this sheet today, but then on Monday we'll actually practice balancing equations. So your job for the video and for homework is to do this worksheet where it has you practicing writing the equations out. So you're responsible on this homework sheet for basically the first page. The second page where you're constructing a flow chart, you'll do that on Monday for homework. This is what you're responsible for now. So let's go ahead and take a look what constitutes and makes up a chemical reaction. So a chemical reaction is basically when you are switching around atoms and creating new substances. Now, when we talked about chemical and physical changes, we talked about a few things that indicate a chemical change, and those also indicate a chemical reaction because a chemical change is a chemical reaction taking place. So color change is the first one. If you take a copper wire here, for example, put it in water, that copper will dissolve, so to speak, within the water, and you'll get a blue solution. So that indicates to you a change has happened. Temperature change, that's if it goes up or if it goes down. If you're keeping track of temperature, that will mean something's going on, something's changing and giving off or taking on energy. The release of energy then in the form of heat and light, basically when something catches fire, explodes, releases a lot of heat, the temperature may rise very quickly. Those are another way that we can indicate a chemical reaction. Appearance of a solid, that's pretty important. We see that a lot. The solid itself is called a precipitate, and we will get into that later, so you don't have to worry about writing that down. But basically, you get a solid that forms within your solution, and here's an example of a few, and that indicates a chemical change. So you've produced something new, which is a new substance, and it's a solid. Odor and gas formation, those kind of go hand in hand. And usually we see that in the form of bubbles. So if something is bubbling or there's a certain smell, that typically indicates a change. Now, colored gases are always poisonous, so make sure you're not inhaling those at any point. So let's look at what it takes to write out a chemical reaction or an equation to represent that. So typically we put the reactants on the left side and the products go on the right side. And when we list those things, it's really important for a reaction to list what state that they're in. So we can kind of think about what it is we're doing, what those substances look like to start, and how they end up. So you will list on the reactant side all of the different compounds typically that are doing the reacting or that you're putting together. But you have to list what state they're in. So for example, G would follow any formula for a compound that is a gas. You would put G in parentheses literally right behind that formula. And we'll look at that in a minute. Same thing for liquids and solids. You have an L and an S. Aqueous might be something new to you. Aqueous or agua is for water. So aqueous solutions or things basically means you're taking a solid and dissolving it in water. And when you do that, the solution is then called aqueous. And typically, a lot of times we'll get ions that form in the water when we dissolve certain things. Okay, the arrow up here is basically the equal sign for your equation. So reactants and products are split up by the arrow. The arrow means yields or forms. So basically the reactants then form or yield a certain amount and type of product. Each type of compound that we have in a reaction, when we list out those formulas on each side, we separate with a plus. So you never put minus signs in a chemical equation. You're always adding together things, and that produces a certain number of products. So these are the things that we want to include in our equations. So the first type of thing that we look at is what's called a word equation. So if you're given a sort of word problem, you want to be able to pick out the pieces that indicate what's a reactant, what's a product, and what type of state are they in. So if you underline some of the keywords, one thing to look for is basically the divide between what's a reactant, what's a product. So words like result, or form, yield, produce. Those types of things indicate any words or compounds that come before that are typically what reacted and thus produced whatever products you have on the other side of that word, which is essentially your arrow. Okay, so here we have, we start out, we say a solid piece of iron. Okay, so I would put down iron in a solid. Now the 3 comes in later on in the word, so then I kind of know I have iron 3. So you can put that down. And it says a solid piece, so we put an S behind that. Plus, it's placed into a flask containing chlorine gas. So the iron and the chlorine gas are put together. So then you have chlorine, put a G for gas. And then it says the reaction takes place that results. So that's where your arrow is. Arrow is basically the results. Okay. In a rust-colored solid. So you know you have a solid, and that solid is then called iron 3 chloride. Okay, and then you literally just list that out. So that's kind of at the end. I know that I have iron 3, so I can put that in the beginning here as well. Okay, so that's a word equation. So you want to look for those keywords. Now, if I want to actually look at formulas and kind of figure out how much of everything is reacting, potentially, that's when I start writing the skeleton equation. So a skeleton equation is transferring those words into formulas. So here is where it's really important to know chemical formulas from the name. So I'm not going to give you any of the ionic formulas or covalent formulas or acids and things like that, because we learned how to name those and how to write the names from the formulas. So that's where this is going to become really important. So if that's still an issue for you, make sure you see me. Acetylene gas. Now that's something we haven't named. We haven't named anything like this. So if it's something I know we haven't done, then I will give you the formula for that. So don't worry. So let's go ahead and read. We have acetylene gas reacts with gaseous oxygen to form. So form is kind of our dividing line, essentially our arrow. Okay. So on the right side or the left side of the arrow, the reactants, I have acetylene gas. So C2H5, and that is a gas. Plus, we always separate everything with plus, gaseous oxygen. Now, you're probably tempted to just put an O and a G behind it. It said it was a gas. Now, oxygen was one of those covalent compounds that we call diatomic molecule, and that means oxygen will bond with itself to become more stable. So oxygen naturally exists in this state. It's always going to be 2 oxygens. Okay, so you want to make sure you remember that. Oxygen is diatomic. And there was a list of those in your covalent notes, section 9.1. So if you need to refer to that, please do. Okay, so now we're forming carbon dioxide. Okay, so carbon is a C, oxygen is an O, and it said dioxide. So di means 2, so I have O2, CO2. This was a gas. Plus liquid water. Water is H2O, or the formal name dihydrogen monoxide. And then I put behind that, I have a liquid, obviously, for water. So that would be my skeleton equation. Now this isn't balanced yet. If I want to balance an equation, I want to make sure I have equal things on both sides. So an equal number of reactants and an equal number of product. So let's take a look at how we do that. And I have a list of steps written on your notes. And I'm going to kind of just talk through those. Those are there for you for later to kind of look at and make sure when you're doing your homework later on that you're in a good place. So let's take a look. We have various coefficients and subscripts, different numbers written everywhere in these equations. So we have our skeleton equation, and then we balance it with the numbers. So a lot of times in the skeleton equation, we'll start out with subscripts. So something you might get when you crisscross to write a formula, or things you know from diatomic molecules, that sort of thing. So those are already in there, and that tells you how many of each individual atom you have in that compound. The big numbers out front, or the coefficients, tell you how many of that unit you have. So for example, here on this I have chlorine, which naturally exists as Cl2. Chlorine is also diatomic. That tells me in each unit I have 2 chlorine atoms, and then I have 3 of those things. So altogether, if I wanted to know how many chlorine atoms I had, individual pieces, I would take the subscript, which is a 2, times the coefficient, which is a 3, and that would give me 6 total chlorine atoms. Same thing over here. I have a 2 outside and a 3 written here because this is, for example, iron 3, so I have to have 3 chlorines to balance it. And that will also give me 6 chlorines. Now, when we balance an equation, you have to have equal reactants and products. So here you can see I have 2 irons, and then 6 chlorines on each side. I can't randomly create and destroy matter, so if an equation is balanced, it demonstrates to me I've conserved mass, or I've followed the law of the conservation of mass, which is a good thing. And a legal thing, but we always need to make sure we follow. Alright, so here's our first equation we're going to balance. Here's what I typically do when I balance an equation. You've got to know how much you're starting out with on each side. So I look at each of the individual elements and I write out the starting number. So I have sodium, which is Na. I have 1 of those. Oxygen is listed next. I also have 1 of those total on this side. Hydrogen, I have 1 of. Calcium, I have 1 of. And bromine, I have 2 of. Okay, this little subscript 2 tells me I have 2 to start. Then on this side, what I typically do to not get confused, however I list the reactants over here, that's how I list the products. So if I listed sodium first, I'm going to do that over here too, just so I can keep it all straight. And I would do that throughout the equation. Alright, so here I have 1. Now, on the oxygens, here's where you want to be careful. Oxygen is in this parenthesis, okay? There's 1 in here, but this 2 out front indicates I have 2 of this thing, hydroxide, OH. And that means I then have 2 oxygens. So you always want to take, like, imagine there being a little 1 here. 2 times 1 will give me 2 oxygens. Same thing with the hydrogen. Calcium I have 1 of, because that's not in that parenthesis set. And then bromine I have 2 of. So that's where you want to start. Get everything listed. Then what you typically want to do is balance something that's all by itself in an equation. So, oh, I'm sorry, on this side I have 1 bromine, not 2. Sorry about that. Okay, sorry, I had to pause for a second. But anyway, we should have 1 bromine over here. So then the next thing you want to do is look for one of these elements that's only listed in 1 compound on each side and try to balance that first. Always save hydrogen and oxygen for the end to do that, and that usually they'll kind of balance out at the end without having to change any other stuff. So I'm looking here, and bromine is the one that's not balanced. So on this side, if I want to get 2 bromines, I'll have to add in a coefficient of 2 here. Okay, so then my equation will look like NaOH aqueous plus CaBr2 aqueous yields calcium hydroxide, which is a solid, plus 2 NaBr. Okay, then I calculate again and see if everything's balanced. So sodium shouldn't have changed. I still have, I have 1 on this side, 1 oxygen, 1 hydrogen. Calcium I have 1 of, and then bromine I have 2 of. So then on this side I have 2 sodiums now. I have 2 oxygens, 2 hydrogens still, 1 calcium, and now 2 bromines. So that's good. So then I look for the next thing, for example, I would look at would be calcium. And if that wasn't balanced, that's where we would go next, because that's an element that occurs just once in a compound. So then I'm going to go ahead and balance out the oxygens. So that means I'm going to have to put a 2 in front of this, a coefficient of 2. Okay, and then when I do that, I'm going to recalculate everything. And typically I would kind of write this again separate, but for lack of space, I'll just go ahead and stick this in. So that'll change 2 sodiums, 2 oxygens, and then 2 hydrogens. Okay, so then everything is balanced. We'll go over the other two examples tomorrow. You're responsible again for the first page on the worksheet, and then we'll be doing balancing practice, sorry, not tomorrow, on Monday. So have a good weekend and make sure you get the worksheet done.